Hey everyone, welcome back to another video. So this is the last little video we're going to do on this subject. So let's jump into it. So this is the inverse of a function. That's what we're going to be looking at, is the inverse of a function. So we're going to learn how to solve for inverses, and we're going to be able to tell at the end whether or not a function will have an inverse function. Some functions don't have inverse functions, and we're going to look at that. All right, so let's jump into this. So let's go right down here to inverse and figure out what we're going to do. So we're going to find the inverse of this function. So here's what we're going to do. We're going to replace the x with a y, and we're going to replace the f of x with an x. Okay, so we're going to look at the equation like this. Let me make this a little thinner here. Okay, so we're going to replace this f of x with an x. Make it a little bigger. All right, and then we're going to replace the x over here with a y. And then we're going to solve this equation for y. We're going to solve it for y, so we're going to get y by itself. So first step is we're going to add that 1 over to the left. So we'll have x plus 1 equals 3y. Next, we'll divide by 3. So we'll have x plus 1 over 3 equals y. And this right here is the inverse of this function. So this is the inverse function. So pretty straightforward. You're just replacing essentially the x and the y and then solving for y to figure out your new function. So our original function was 3x minus 1. Our inverse is x plus 1 over 3. All right, and we can see kind of the symbolism here as well. So if we have this function f of x, then the inverse of that function would be represented with a little minus 1 in the top right corner. So just realize that the little minus 1 means inverse function, All right, let's see. Let's find the inverse of a quadratic function. So we have this function f of x equals x squared. So let's find the inverse of that function. So again, we'll replace the f of x with an x and the x with a y. So we'll have x squared x equals y squared. Then we want to solve for y. So how do we get rid of this 2? Remember, the opposite of square is square root. So we'll have y equals the square root of x. And that's why it's saying that x has to be greater than or equal to 0, because we can't have negative x's under our root. So here's the inverse. The inverse function of x squared is square root of x. All right, same rule. All right, now the horizontal line test is an interesting test. It means that if you draw a horizontal line anywhere on a function, if it crosses more than one time, anywhere, then that means that it is you're not going to have an inverse. You're not going to have an inverse function. So the inverse of it won't be a function. However, if the horizontal line everywhere on a function only crosses one point, never crosses more than once, then it will have an inverse. So if we look at this function right here, let's determine whether or not it has an inverse. So we'll pull up Desmos here, and we'll graph this function, 2x cubed plus 1. Okay, take a look at this. Is there anywhere on this function where it would cross more than, if we put a horizontal line, is there anywhere where it would cross more than one time? And I don't think there is. Right here, even though it's just like barely going in, it's only crossing at one point right in the middle. So this will have an inverse function. All right, and then let's find this inverse. So again, we'll replace the f of x with an x and the x with a y, and we'll solve for y. So let's subtract 1, so we'll have x minus 1 equals 2x cubed. Divide by 2, so we'll have x minus 1 over 2 equals y cubed. And then the opposite of cube is cube root. So our final function will be y equals the cube root of x plus 1, or I'm sorry, x minus 1 over 2. So there you go. And then finally, let's see, we're going to determine whether the inverse of this is a function. So let's try that out. Let's type it in. So we got 2 square root x minus 3. Okay, let's look at this function. Is there anywhere on this function where a horizontal line will cross more than once? And it doesn't look like there is. So this will have an inverse. Let's find the inverse. So let's replace our, let's change colors here. Let's change our f of x to an x. Square root of y minus 3. Okay, first step here, we want to get rid of this 2. We want to isolate this square root. So let's get rid of the 2. So we'll have x over 2 equals the square root of y minus 3. Next, we want to get rid of that square root. Opposite of square root is to square. So we'll put this over here. We'll have x squared over 2 squared, which is 4. So we can square the whole x over 2 equals y minus 3. That's how we got rid of that square root. And then we just add 3. So we'll have x squared over 4 plus 3 equals y. So here's our new inverse function. All right, one more. We're going to determine whether these two functions are inverses of each other. So what we can do is just take one of the functions, find the inverse, and see if it matches that function. So let's do that. Same process, x equals 3y minus 1. Add the 1, so we'll have x plus 1 equals 3y. Divide by 3, we'll have y equals x plus 1 over 3. And we can see that these are the same. So yes, these are inverses of each other. This is an inverse of this function. All right. So guys, that is inverse of a function. If you have any questions, let me know. But thanks guys for watching, and I'll see you next time.